Good evening, everyone. Welcome back to LumCon Science Talks. For those of you who are joining us for the first time, you can interact with all the staff that you see up on your screen right now by using the question box. So you should have a dashboard somewhere on your screen, and one of the options that you should have is ask a question. It'll be in a dark gray box that says question, and that's how you can communicate with us on this side, and we can communicate back to Andrew.
Wait a minute, Mark, so is the question box, it says question? I just want to make sure.
Right. I need, I don't know what I need, but I do need to tell my jokes because some of you need to hear my jokes.
Yeah, Andrew and I are waiting patiently.
All right, here it goes.
I've been working on my groans all day long.
Yeah, we've been placing bets.
All right, I really tried harder this week, so here we go.
Oh,
First
no.
question. So audience, feel free to chime in some of your suggested answers to these questions. First question, why did the detectives, i.e. Andrew, show up at the concert on the bayou? You give up?
Oh yeah.
Oh, I gave up a long time ago.
Because something fishy was going
on. See, that's a groan. Appreciative groan.
The next one.
Everyone out there is slapping their head somewhere.
Yeah.
No, they're feeling sorry for me right now.
Sorry for you. Should they be feeling sorry for us?
I think we just lost 10 people.
Our attendee numbers are going down, so I'm assuming they're either not paying attention or really enjoying this right now. All right, second question. William says he's getting his money worth.
It's worth every bit of the free.
Every bit of it. He's earning it, so to speak. All right, so why do elephants always get kicked out of the bayou? Any guesses? Audience, any guesses? All right, the answer is, gotta get ready for this one. Because they keep dropping their trunks.
Oh, no. No.
Sorry. Those were the funniest ones I could find related to bayous. All right. With that, I'm going to turn it over before I further embarrass myself. And
I like how you always drop these bombs and then just like, now it's your turn, Craig.
Well, next talk, Craig, you bring the jokes.
Oh, okay. I will.
Yeah?
Challenge
Yeah,
accepted.
you want to?
Talk, I will bring.
Oh, that's fantastic. I'm looking forward.
Fun.
Oh, yeah.
All right.
Yeah, you can be on the receiving end of the bad jokes for once.
I have to share, Greg. Bye, guys. Keep on chatting. I'm getting them and I'm loving them, so keep them coming.
Well, good evening, everybody. Thank you for joining us again for the LumCon online lecture series. I'm Craig McLean, the Executive Director of LumCon, and I'd like to thank you for joining us again tonight. These happen every other Thursday night at 7 p.m. Central. We're going to invite a Louisiana scientist to talk about their research, and then, of course, give you the opportunity to both listen and ask them questions about the extraordinary work that they're doing. And I hope you can continue to join us for these online lectures and explore more of our world from the comfort of our homes. And again, you can always find information about the complete series at our website, lumcon.edu. Just scroll down on our homepage and the link there will be under the news and events. Well, tonight it's my privilege to introduce Dr. Andrew Barron. Andrew's been with BTNEP for 18 years and manages projects related to water quality, coastal restoration, and cultural heritage, and oversees quality assurance for scientific data collection at BTNEP. He represents BTNEP on the Louisiana Watershed Initiative, the Region 6 Steering Committee, the Water Management Advisory Task Force Commission, the Greater New Orleans Master Naturalist Program Steering Committee, the State Master Plan Framework Development Team, and a whole bunch of other various committees. Andrew has also taught physical science, biology, environmental science, and chemistry as a high school science teacher. And he's also worked as an environmental specialist, environmental scientist for the non-point source pollution unit of the Louisiana Department of Environmental Quality before working with BTNEP. And we are very excited to have Andrew join us tonight for both this talk and have our partners at BTNEP join us as part of this series. Thank you so much, Andrew. Looking forward to it.
All right, I'll go ahead and get started. Hopefully everyone can see my screen. All right, so tonight I'm going to talk about the Bayou Folse Watershed Restoration Project that we've been working on. And so this project we're doing this project because Bayou Folse is an impaired watershed. That means that it's not meeting its standards. And I'm going to talk about that a little more later. In the photograph here, you can see this is my colleague, Siva Nuna, and we're out with a couple of students from Nichols who were volunteers for us on that day. And so just to kind of give you a overarching context of the kind of work that we're doing, in my mind, I like to think of there being a scientific glamour index, okay? So from like 1 to 10 scale, at the top of it, you know, at a 10, it would be work like Dr. McLean does where, you know, dropping an alligator into deep water to study how, you know, these giant macroinvertebrates consume the carcass of the animal. Whereas the kind of work that we're doing, it's kind of down near of the scale on like at near 1, because we deal with stuff that people don't consider to be very glamorous. And I'm going to talk about that some more. So yeah, so this is the page just in case people missed who I am. I'm the Senior Water Resources Program Coordinator and Quality Assurance Manager for the Barataria-Terrebonne National Estuary Program. And so first off, I'm going to talk a little bit about the background of BTNEP. What is BTNEP? And so, yeah, so whenever I talk about BTNEP, I mean Barataria-Terrebonne National Estuary Program. And so we are ultimately funded, most of the work we do is funded by the United States Environmental Protection Agency. And so when we were established back in the early 1990s, they established estuaries of national significance. And that was through the Clean Water Act. So that's Section 320 of the Clean Water Act. And so BTNEP is one of 28 national estuary programs. And you can see on this map that we have all of these various national estuary programs throughout the country. And of course, we're located down in Louisiana. We are the only national estuary program in Louisiana. And so this is a map showing our program area for Barataria-Terrebonne National Estuary. So over on the east side, we're bounded by the Mississippi River. And on the west side, we're bounded by the Atchafalaya River. On the north end, it's the Old River Control Structure. And then down at the south, of course, is the Gulf of Mexico. Just to give you a reference point, Thibodaux, Louisiana is here, New Orleans is over here, and Morgan City would be over here. And so just looking at this map, you can tell that the reason the program area is the shape that it is in, it's because we are a watershed program. So our program area is a watershed, okay? It's bounded hydrologically by the Mississippi River Levee, the Atchafalaya River Levee, and Old River Control Structure. So this is an image showing our management conference members. So we have a guiding committee that is called the Barataria-Terrebonne Management Conference. And a management conference is just kind of like a management committee that helps to guide us in the implementation of our comprehensive management plan. So we have our comprehensive management plan is actually called a comprehensive conservation and management plan, and it is made up of action plans. So action plans are these tasks that we need to implement in order to restore the estuary. And so these are all the members of our management conference who help to guide us in the implementation of that CCMP. And you can see it's made up of a huge variety of public and private agencies, entities. LUMCON is also represented on our management conference. And this is a photograph from a couple of years back of one of our meetings that we held. And we hold these meetings every quarter. So every 3 months we hold a management conference meeting. And so the members of the management conference, they help us by guiding us again in the implementation of our CCMP. And this is the structure, like we call that our implementation structure in this slide. So our management conference, they're the overarching people that we have to answer to in terms of the implementation of the environmental work that we do. And that works through the program office. So I work for the program office. Okay, so we're like the worker bees who are out there actively trying to implement the CCMP. Various members of our management conference at any given time are implementing parts of our CCMP. The way that we develop, so every year we put in a proposal that is funded through EPA Section 320. And so the way we do that is we host action plan teams, and our action plan team members submit ideas that we're going to use to incorporate into our work plan to be approved by the management conference and ultimately going to EPA for the funding. We also have a private foundation called the Barataria-Terrebonne Foundation. And they are available if you're interested in donating to them. You can easily find them on our website, btnep.org, if you are interested in them. And so finally, we are administered through LUMCON. So I'm a LUMCON employee. All members of who work for BTNEP are LUMCON employees. So LUMCON is our fiscal and administrative agent. They're the organization that oversees everything. Any of the federal grants that we get coming to us go through LUMCON, and LUMCON handles all of that for us. And in case I didn't mention it before, I just wanted to say thank you to Mert and Dr. McLean for inviting me to come and talk tonight to you all. And so with that, I will continue. So now I'm going to start getting into more of the scientific portion of my presentation. and I'm going to talk specifically about the work that we're doing for the Bayou Folse Watershed. And so, like I mentioned before, Bayou Folse is it's a pretty severely impaired water body. In fact, I often call it the poster child for problems we see across Louisiana in our coastal watersheds. And you'll see what I mean by that as we go on. So our goal is really pretty simple. It's pretty straightforward. We want to improve surface water in the Bayou Folse watershed for dissolved oxygen, fecal coliform, and for nutrients. So as I go through the presentation, you're going to see some slides with DO on it or FC. And what I'm talking about is dissolved oxygen and fecal coliform. And so I have various objectives that are part of our mission, our overarching project. So this project, when you work in a watershed, it's very difficult for one particular agency to go in and be able to correct the problems that you find in a watershed. When you're doing watershed work, you need to partner with various agencies and entities out there. And it's years of work just to kind of set the stage. And so we have two different components that I'm going to talk about that are being used to try to address the issue of fecal coliform. Okay, so the first part, and I like to refer to those two different parts as the carrot and the stick. And so the first thing I'm going to talk about is the carrot, okay? So GMP stands for Gulf of Mexico Program. They are under EPA, and one of our objectives is to use money from Gulf of Mexico Program to fund our foundation to go out and fix home sewer systems. And how do we do that? As part of the objectives, we were planning to go out and contract with South Central Planning and Development Commission, that's SCPDC, to pay homeowners directly to fix their home sewer system. This is kind of an innovative approach. If you haven't heard about it before, it's probably because people haven't really done this sort of thing, okay? So a couple of years back, I worked with my action plan team and my colleagues to come up with a way that we could do this. And you're going to learn more about that in the presentation. Also, we have other objectives, and this is the stick approach, okay? So this would be, we're working with Department of Environmental Quality, that's LDEQ, to fund water quality sampling and inspections in our watershed. And then we will, so BTNEP, our role is to conduct sampling of water quality for dissolved oxygen, fecal coliform, nutrients, pH, clarity, and water temperature. And that water work is being funded by Louisiana Department of Environmental Quality. And so as you're going to see, we're kind of cobbled together these various different partnerships to address these different problems we're seeing out in the watershed. Also, we are working with Bayou Lafourche Freshwater District. It's almost like, you're going to hear almost like a alphabet soup of all these different agencies that we're working with. And so BLFWD stands for Bayou Lafourche Freshwater District, and we are working with them to inspect home sewage systems as part of the stick approach. And then finally, we also, as part of this project, plan to work with NRCS because they went out and obtained NERDA and Restore Act funding. And that's really to focus in on nutrients that we have in the watershed from row crop and pastureland runoff. And so the end goal there was for NRCS to form a relationship, a partnership with Ducks Unlimited, that's what DU stands for, to work with farmers to address the nutrients, okay? So we have a multi-pronged approach here where we're trying to work all together as partners to try and restore the watershed. So this is a photograph of the Bayou Folse Watershed, kind of what you might expect. This is a photograph from one of our sites down near Lockport. And this little canal is actually a drainage canal coming from a pumping station going directly out into Company Canal. For those of you who are familiar with our area down here. And so this is a map of Louisiana showing all of the various watersheds within the state that are impaired. And of course, this blue arrow down here is pointing to the location of the Bayou Folse Watershed. So that gives you kind of an idea geographically of where this watershed is located. It is one of our coastal watersheds. And like I said before, it's pretty severely impaired. You know, the poster child of problems you can expect in a coastal watershed. And so zooming in a little closer, this is showing the outline of our estuary that I showed you before, the satellite image I showed you before. But in this case, it's showing all of the sub watersheds within our estuary. And it's zooming in. You can see that Bayou Folse watershed in yellow here is right smack dab in the middle of our estuary. And so we're going to zoom in down to the scale of the actual watershed. So this is a map showing the land use and land cover of the Bayou Folse watershed. Now, when you do watershed work, one of the very first things, I learned this from my former boss when I worked at in the 319 program at DEQ. The very first thing you have to do is you need to get a good land use map. Okay, so what does that mean? That means that you have various different land uses that occur at different places within your watershed. So if you notice up here along the Bayou Lafourche Ridge, in purple, you have a lot of sugarcane, and you have a lot of grass and pasture land in kind of these polder enclosures. So anytime you see a straight line, you know, on a map, that indicates it's a man-made feature. So these are actually levee systems, all right? Levee systems all around these blocks of land. Over in Europe, the Dutch, they would call this maybe a polder, okay? But over here, we call that a forced drainage area. Sorry, I advanced the slide accidentally. So these are forced drainage areas. So what it means is we've put in flood protection levees. So our levee district put in a levee all around this area. And then there are stormwater pumps throughout that pump those areas out whenever it rains. Okay, so this gives you kind of the lay of the land. The rest of this stuff in green, that's a lot of wetlands. These are natural wetlands that occur within this watershed. And so, of course, at the north end, at the upper end of the watershed, we have Thibodaux, the city of Thibodaux. And then you can see Raceland marked on the map. What isn't marked down here, this is Lockport. So at the very bottom, you have Company Canal, which I showed you in the photograph. That's Company Canal. And so the water starts up here in Thibodaux, runs all the way down, either through Lake Fields or right past Lake Fields, and then into Company Canal. All right, so when we talk about a watershed is an area of land that is bounded hydrologically. So what is Andrew talking about? You know, it's a big word, but what it means is that you have high areas over here on this side, and you have a high area over here on this side. So you can imagine anytime it rains inside of this area, it all gets funneled to a central water body. And so that is why it's called a watershed. Just to be clear, a watershed is not the little shed you have in your backyard where you keep the water, as I've had plenty of people tell me when I ask them. But a watershed, again, it's a geographic area of land that's bounded hydrologically, and when it rains, that water flows through a central water body. So I've probably spent plenty of time on that now. Hopefully everyone's on the same page as to what it means to have a watershed. Okay, so as it turns out, Bayou Folse, like I mentioned before, its headwaters are up in Thibodaux, Louisiana. And that also happens to be the home of Nicholls State University. And it also turns out that is where our office is for BTNEP. Even though we work under LumCon, we're under LumCon, LumCon's main facility is down on the coast. It's in Cocodrie. It's in, in the danger zone down there, outside of the levee system. But for BTNEP, we are located in North Babington Hall here on Thibodaux, on Nicholls campus in Thibodaux. And also, as it turns out, the headwaters of the watershed we're talking about today, Bayou Folse, starts, it comes right out right here. This is a photograph of where the headwaters begin, which is essentially draining out of the baseball fields, and I think it might even be the football practice field for Nicholls State University. As you move a little farther downstream, it is bounded by sugarcane fields here. You may not be able to see it very well, but that's sugarcane growing. And then there's residential areas all around it, okay? And we're gonna move a little farther down. These are some apartments that were recently built, and this is not far, maybe within 2 miles from Nicholls State University campus. It goes under this bridge here, and this is near our very first sampling site number 1. In fact, that culvert there is where we collect our samples. This is right after, you can see this is all dredge spoil. And so the North Lafourche Levee District had just come through here within like the previous month or two and dredged out the bayou. So I'm gonna start talking about, so let's kind of take a step back and we're gonna talk about some of the basics when it comes to water quality. Generally, if you looked at Section 320 or Section 319 of the Clean Water Act, if you looked at the Clean Water Act, they frequently talk about sources and causes. So the first thing I'm going to talk about is sources. Okay, so what is the source of an impairment? All right, so all water quality standards are based on uses. Okay, so what does that mean exactly? So if you notice in this column over here on the right, it has designated use. So that's what I'm talking about when I say uses. So you have different uses of a water body, even though it's the same water body. Some people use it for fish and wildlife propagation. What does that mean? They go fishing. Primary contact recreation. That means that the water body is used for swimming. And so there are 2 basic standards that all water bodies in the United States have to meet, and that is fishing and swimming. When EPA, when they put together the Clean Water Act, all water bodies, EPA wanted all water bodies to have these be designated uses as fishing and swimming, okay? So it has to be fishable and it has to be swimmable, all right? And so then how do we decide? How do we decide whether or not this water body is meeting its designated use? Well, we have to assign standards. So for, say, fish and wildlife propagation, the main standard for fish and wildlife propagation is oxygen. Okay, so dissolved oxygen. When you talk about the parameter dissolved oxygen, that is there to protect the fish. That's not to protect human health. However, just below that, whoops, just below that is pathogens, okay? So that is to protect human health. And the parameter we measure for that is fecal coliform. So I'm going to be talking mainly about fecal coliform and dissolved oxygen in this, but I'm also going to be talking about nutrients like nitrate, nitrite, phosphorus. And so the nutrients go towards fisheries health. And the main thing that goes towards human health is going to be pathogens. And then again, for fisheries health, oxygen is going to be a huge factor. And we're going to talk more about that as I go through the presentation. And so now, just like I just talked about sources, we're going to talk about causes. What actually causes the impairment? Okay, so in Bayou Folse, one of the main problem that causes impairment for human health, the human health standard, is going to be fecal coliform bacteria coming from malfunctioning home sewage systems. So here's a little bit of trivia for you. So I always say this, if we were able to solve the problem with malfunctioning home sewage systems, we probably would have 90% of all water pollution solved. And now this is not just a problem in Louisiana. This is a problem throughout our country. Malfunctioning home sewage systems, when I talk about that, I'm talking about an individual home sewage system. I'm not talking about like a community sewage treatment plant or a municipal sewage treatment plant. I'm talking about individual residences that have sewage treatment plants on their property. And so these are photographs of malfunctioning home sewage systems. If you're going along Bayou Lafourche, you know, you're riding in a boat and you see pipes coming out and there's a discharge there, that is, you know, there's a good likelihood that's coming from a home sewage system. Now, whether it's malfunctioning or not, you know, we would have to actually measure that. Another source of these pathogens of fecal coliform bacteria is pastureland runoff. So that's from like cattle grazing. That's what we mean when we say pastureland. We're talking about cattle or any other kind of livestock that would be out on the land grazing and then potentially pooping in the water. Okay, in the case of this photograph, this is from one of our sites. And, you know, during the summer, virtually every time we go out there, you can see that cattle are going down into the water to cool off, to drink the water, and of course, to do their business. And you can see, you know, there's other impacts that go on here. In addition to the cattle pooping directly into the water, they also cause erosion along the stream banks. Now, this is something that can be fixed fairly easily by putting up a fence. And so when I mentioned NRCS before, that's the Natural Resources Conservation Service, they are going to be working with farmers to try and do some of these best management practices like putting in a fence to try and prevent the cattle from going into the water. And that can help to prevent a lot of problems, as we're discussing. Another problem related to agriculture is row crop agricultural runoff. And so this is sugarcane growing in rows, of course. And so the main problem, the main cause that comes from row crop agriculture is going to be nutrients, okay? And that's another issue, another problem that NRCS is going to be working with us to address. All right, so now I'm going to come down to kind of the project level discussion. So I'm going to talk about methods that we are using when we go out there and do this sort of watershed management. And so if y'all remember, this is our watershed. This is the Bayou Folse Watershed. And so if you notice these yellow dots, okay, that is our these are our sampling sites. It's a transect going down through the watershed. And so we go and collect data every 2 weeks at each of these sampling sites. And so at this point in time, we've been going out since 2016. So it's been 4 years of work so far. And we've collected we've gone out on 76 different sampling events. So we have a huge amount of data, and I'm going to show you all the results of some of that. So moving right along. And so we go out, like I said, and collect water quality data every 2 weeks, and we've been doing that pretty consistently for the last 4 years. This is me, of course, out there with one of our volunteers, and this is my colleague, Sivanuna, out with another student volunteer from Nichols. And so when we go out, every time we go out and conduct a sampling event, we collect certain parameters. And so a parameter is basically a characteristic of a water body. Okay, so just like you could look at me and you could make you could describe Andrew. Okay, he's wearing a black shirt and he's wearing white shorts and he's bald, you know, whatever. Certain characteristics there. Okay, so that's what we're trying to get at when we go out and measure and collect this water quality data. And so we use various instruments and devices to do that. So the first one is what's called a hydrolab. It has these different probes on it. So like a probe that measures dissolved oxygen, pH, salinity, temperature, and you have those different probes that are part of this larger device that's called a sonde, S-O-N-D-E, sonde. And so we also collect water clarity. And so some of you might be familiar with what's something called a Secchi disc. It's a disc that you lower down in the water, and it enables you to see the photic zone, or how deep light is penetrating the water. Okay, it's got a black and white pattern on it. And then we collect also stage height. We use this device called a tape down. And so you drop it from a bridge as a benchmark down to the very surface of the water body. And that gives you a stage height. At one of our sites, which is called our ambient site, we also collect velocity data using oranges. And I think Craig is probably saying to himself right now that, oh, that's why you send me these requests for purchasing oranges all the time. You know, what are those people at BTNEP doing? So what we do is we drop an orange from one side of the bridge to the other. That gives us a velocity. And then we use the stage height in combination to aerial measurements, or bathymetric aerial measurements across the bottom of the water body, and we can calculate flow from that. And we can talk about that a little more later if anybody's interested in that, or they can contact me directly. We also collect grab samples. So we actually physically collect, you know, a collection of water in a bottle and take that to laboratories where we have various nutrients that get analyzed, you know, nitrate, nitrite, total phosphorus, organic nitrogen, also known as TKN, or total Kjeldahl nitrogen, and then also finally fecal coliform bacteria. So with fecal coliform bacteria, we have a certain amount of time from the point in time that we collect the sample. We have 6 hours to get it to the lab, even though the sample, the bottle itself has a preservative in it and we keep them on ice. We still have that time limit, you know, that we have to get it to the lab, just to kind of give y'all an idea of what we do. So we also conduct a lot of water quality education. We work with public groups. In this photograph, you can see these folks are looking down through this tube. This is using that water clarity technique. So this is called a Secchi tube because you can pretty much see the black and white pattern at the bottom there. So this person is, we fill up the tube to the top and then we let it go down until the point in time where we just start to see that pattern. Okay, so that gives us, again, the photic zone or the depth of light penetration. This group that we're working with here is called the Louisiana Master Naturalist Program. I'm actually a board member and I'm an instructor for them. And you should check these guys out. They do some great work. And I would say that they are the only venue, or one of the most effective venues, I should say, for public education. It's all science-based too. It's really cool. And then we also go and give presentations to gardening clubs. So this is Terrebonne Parish master gardeners, as opposed to the people in the previous slide who were master naturalists. So yeah, we present to public groups, and we of course go to school groups, K-12 groups. This is a summer camp of kids, and Siva is doing some watershed education with this this model called an Enviroscape, one of our tools that we use for education. And then we also do, like I said, summer camps. We did macroinvertebrates, which are organisms in the water that are indicators of water pollution or water health, okay? And this little guy is showing me a damselfly on his tweezers, and he's very proud of that one for that day. And so then now I'm going to go into some of the scientific data results that we've collected as part of all the work that we've been doing. Okay, so remember I talked about uses and standards. And so the first data I'm going to show you is the percentage of dissolved oxygen excursions. So Andrew, what are you talking about? What is an excursion? An excursion is when you are outside of the standard for a particular event. Okay, so you can see here N equals 76. What does that mean? That means we went out on 76 different sampling events. And if you look over here on the left side of my graph, that's the percentage of excursions. So that's the percentage of times each sampling site has been in violation of its standard for dissolved oxygen. So dissolved oxygen is an indicator of how healthy the water is for fish. And so you can see that this water body is pretty severely impaired for fish and wildlife propagation. Okay, so that again, so this is for fisheries health protection. That's what dissolved oxygen, when we measure that, that's what that's doing. The next slide is showing the percentage of excursions or violations of the standard for SCR and PCR. Okay, so what is that? SCR is the secondary contact recreation standard. Yeah, so when we talk about fecal coliform bacteria, it gets a little more complicated. So secondary contact recreation, that means that's a standard that is set. It's based on what's the probability of you getting sick if you're riding around in a boat and you get some of the spray from the water. So as you would guess, the secondary contact recreation, if it's someone riding around in a boat, it's probably not as stringent as the primary contact recreation standard. The primary standard is if you're actually down in the water swimming, okay? So it's going to take a lower concentration of bacteria to get you sick. All right, so if we look over here on the right-hand side, FC greater than 2,000, that's supposed to be 2,000, not 200. The zero wrapped around to the next line, but that's 2,000 colony forming units. Okay, that's a unit of measuring fecal coliform bacteria. Now that's in yellow, and you can see that the number of excursions are less than 50%. Okay, we'll just say that it's less than 25%. I think in the regulations, it's supposed to be over 25% consistently across your events. All right, but if we look at the primary contact recreation, and again, this is if someone's out there swimming in the water, it's a lower concentration and it's only in effect between May and October. All right. So this standard's only in effect for part of the year. The secondary contact recreation standard is in effect throughout the year. And so, even during the warm summer months when this primary contact recreation standard is in effect, you can see that for many of my sites here, we are in violation of the primary contact standard. Okay, and that's a big problem. That's a big problem. So the next parameter I'm going to talk about is pH. And pH, as many of you probably know, is a measure of the acidity in the water body. The reason I want to show y'all this, just to show y'all the nature of this watershed, and this is not uncommon. This is pretty common in these coastal watersheds. These coastal watersheds have a lot of wetlands in them. And so I want you to look at the minimum values and the maximum values. Okay, let's look over here at this one right here. 6.13. That's a pretty low value for natural waters. Okay, and look right next to it. The highest value at the exact same site has a value for 8.92. That's a very high pH range. That's orders of magnitude in difference. Okay, and so on the low end, this low pH value is probably driven by the acids, the organic acids. These are naturally occurring, coming out of the wetlands that make up our watershed. But on the high end, it's probably due to the photosynthetic cycle or carbonates coming in from seawater. So this watershed, again, it's a coastal watershed. These coastal watersheds have a huge variation. Most of what we would call tides are driven by wind. Here in Louisiana, we have actually a very low tidal range, maybe about a foot to almost, maybe a foot and a half, and that's really pushing it. Most of the water fluctuations in height and everything else is driven by wind, okay? And so what we have in our watershed here in the Bayou Folse Watershed is called bidirectional flow. It flows in two different directions. It'll flow upstream, it'll flow downstream. I've literally been out there while I was sampling, watching the motion of the water switch from going downstream to upstream. And of course, if you're trying to decide where is the source of the pollution coming from in your watershed, this makes it very challenging. All right, so moving right along. So the next parameter I'm going to talk about is one of the nutrients. There's 3 nutrient parameters. This one is nitrate, nitrite average. Okay, so if you notice, up here, site number one, if you notice some of the previous data we were just talking about for fecal coliform and dissolved oxygen, this particular site is a problem child within the watershed that is a problem child. We frequently see, this is the site that's up near Nicholls State University. It's actually located near a brand new subdivision. And it's the irony of it is that it's near actually a lot of sewered areas. So we're not completely sure what's going on there, why we have consistently high fecal coliform levels, low dissolved oxygen, as well as high nutrients from nitrate, nitrite at this site. You can see there's sort of a pattern as you go downstream. It kind of dips down and comes back up at site number 9, but you're going to see that this kind of varies with each of the parameters to some extent. And so TP doesn't stand for toilet paper. Of course, it stands for total phosphorus in this case, TP. And so for this one, most of our samples on average come in around the 0.3 milligrams per liter. And in case you're wondering, milligrams per liter, it's like parts per million. It's essentially the same type of metric or unit. But so, yeah, right around 0.3 milligrams per liter, except for site number 10. And the reason the average is so high for site number 10 is because we had one particular anomalous event. The value, if I remember correctly, was around 26 milligrams per liter. That is super, super high for phosphorus in natural waters. Of course, throughout the watershed, you're getting, you know, sugarcane row crop runoff as well as pastureland runoff from cattle production. All right. And so it's possible that it's coming from one of those sources, as well as, of course, malfunctioning human wastewater treatment systems. And then our final parameter is TKN, or total Kjeldahl nitrogen. This is nitrogen bound in the organic fraction of the water body. So if you look down in water, you know, you might see like a kind of a dark tea colored, like the organic acids I was talking about when I was talking about pH. So that's providing the acidity, but also there's nitrogen bound in that organic fraction. All right. And so that can also provide nutrients to the waterway. And again, nutrients ultimately affect dissolved oxygen. So something that you might have a reference to with regard to this is the hypoxic zone in the Gulf of Mexico. So Dr. Nancy Rabelais at LumCon goes out every year on a cruise in July, and she looks at a transect. She goes out and measures along that transect, you know, the dissolved oxygen, the level of nutrients, all of that. And the dissolved oxygen out there that drives a hypoxic zone ultimately is being fueled by nutrients. Okay, so the nutrients coming out of the Mississippi River drainage gets out there into the Gulf of Mexico, causes these algae blooms to occur, and then those algae die, and there's other bacteria down there that they're naturally occurring, but as soon as the algae die, that's like a bologna sandwich for you and me. You know, they're eating that yum, 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 but at the same time, just like us, they have to be able to utilize oxygen to break down that carbon in that algae. Okay, so nutrients play a huge role in fisheries health for that reason, because they can drive down dissolved oxygen. Okay, and so total Kjeldahl nitrogen plays a role in that as well. Now, if you look at this graph, there's really not a discernible pattern going from one of our sites to the other down the transect. And so, you know, so anyway, that's we're moving right along. And so some of our other results I wanted to present is our educational results, just to kind of emphasize how much education we do. You know, when we're not out collecting water samples, when we're not out, you know, writing reports of the data, we're out doing educational events. Just like tonight's venue, you know, this is an educational event for us, and we're trying to spread the knowledge about the serious problems of, you know, people's home sewage systems. And so we do that at various festivals. We do it through media, interviews, websites, brochures, all of that type of stuff. And so now I'm going to talk about what has actually been accomplished. In addition to all the sampling and data collection, we were successful in going out to get money from the Gulf of Mexico program. Remember, that's the carrot, like I was telling you. And we were awarded $426,874 to our foundation back in July of 2018. We wrote a contract with the South Central Planning and Development Commission. And the reason we went with those guys as our contractors, because they have done these sorts of big grants in the past. where they work out individual contracts with homeowners. Now, I'm just saying a bunch of words here, but that is a big deal. That takes a lot of legwork, okay? They have to go door to door, canvass the watershed, and then convince a homeowner to enter in a partnership with us. You know, we are paying them to fix their home sewage system nonetheless, but that takes a lot of work. And so currently, South Central Planning has been out there working out these agreements with homeowners, with these contracts. They go out, do a pre-inspection. The homeowner agrees to do the work. They front the money, and then we come back, South Central Planning comes back, and then they pay them. You know, they do a post-inspection, and then if they see that the work has been completed successfully, they will pay them. And then, of course, the sampling, as I've discussed before, we've conducted 76 sampling events, a variety of different K-12 and public education events. And so when I say DEQ, this is one of our big partners. Most of our funding comes from DEQ, all right? DEQ gets their ultimate money from Environmental Protection Agency. It comes through our state, Louisiana Department of Environmental Quality, and then it comes down to us, okay? And that pays for water sampling, the education, and it also pays for another set of inspections, okay? So we subcontracted that work out with the Bayou Lafourche Freshwater District. That's what BLFWD stands for. These guys are key players in this whole watershed work. Why is that? That's because they have the actual authority to go onto people's property to conduct these inspections. Okay, that is huge. That is the linchpin of all of the work that we are doing right now to try and clean up the water out there. And then finally, NRCS was successful in obtaining funds from NERDA Restore Act funds. And again, they're going to focus in on the nutrients, row crop and pasture land agricultural runoff. They worked out an agreement with Ducks Unlimited. So Ducks Unlimited is actually going to act as the agent of NRCS to go and directly pay farmers to implement these nutrient BMPs. So when I say BMPs, I am talking about best management practices. So for instance, on a sugarcane field, perhaps the farmer goes in and he cuts his cane, and then he uses these harvesters that blow all of that chaff out onto the field. And then frequently farmers will come back and burn that chaff off of the field. Well, perhaps one of the BMPs would be to pay the farmer to leave the chaff on the field. And that will dramatically reduce the amount of runoff coming off of the field. And so in the future, we plan to continue doing our sampling work through DEQ. The monitoring work, we're going to continue doing educational programs, again, paid for by DEQ. South Central Planning, as part of the money coming from Gulf of Mexico program, will continue to do contracts with homeowners. They've already enlisted about 70 homes into the program, and hopefully we'll be able to recruit more homeowners because we just got approval to change the way that we pay homeowners. We're actually going to increase the amount, the incentive that we pay to the homeowners. And then Bayou Lafourche Freshwater District, as of this month, the Freshwater District just began to conduct the other set of inspections in the watershed. So again, that's a big deal. That's a huge linchpin for making this all work together. You know, this jigsaw puzzle of all this partnership, that's a big key player in it. And then finally, NRCS has already entered into the agreement with Ducks Unlimited, and they have already begun to work with farmers and landowners. In fact, Ducks Unlimited is talking to Nicholls State University about using the farm, the Nicholls State University farm, as a wetland assimilation place in the Bayou Folse Watershed. So that is a huge deal. That is really great news. And so I just have to say that this project has been funded in full or in part by the United States Protection Agency. We have actually, it's more than one funding avenue comes from the EPA. And everyone should know that. That's a good thing. EPA does good work trying to protect humans, protect the fisheries, out there in these various watersheds. And this is an example of that type of work. And so, as I mentioned before, I've run through a lot of different partners who are playing various parts in this watershed effort. And so we have a huge number of people here. And like I've mentioned before, we have funding that comes directly from Gulf of Mexico program, DEQ, and the United States Environmental Protection Agency. And then finally, I have this final slide, and I'm willing to take questions now. But before I do that, I just want everyone to realize that if you have an individual home sewage system, whether you're in the estuary or not, the one best thing you can do to help protect the environment, the estuary, and more importantly, your family, is to go and make sure that your home sewage system is working properly. Now, and if you're in the Bayou Folse Watershed, please contact me because we have money to help you fix your system. And with that, that is the end of my presentation. And I guess maybe Mert will come back in and relay any comments or questions to me if there are any.
Excellent. Thank you so much for outlining all the effort, great effort that's being done by many agencies, spearheaded by BTNEP. It's great to see our water resources being protected by so many.
We're trying. We're trying.
So we have had some questions come in while you were talking, but I will give people just a couple more seconds to type out their questions and send them in.
Okay.
So I'll just start with the ones that came in during your presentation, and you may have addressed some scope of these questions later in your presentations, but I'll ask them anyway. So Graham is asking, do you use modeling to help identify sources of pollution within the watershed?
So we do not do any modeling as part of the work that we're doing. However, DEQ, our one of our granting agencies, they do a tremendous amount of modeling. Okay, so if you are familiar with the Clean Water Act, one of the requirements that EPA is required to do, which is usually passed on to the states, so that would be DEQ, is something called total maximum daily load calculations. So that's, if you think about it, it's like, you're eating at the buffet and you can't eat anymore. Okay, so a water body, if you think about pollutants as the food coming into the buffet, going into the water body, that's a calculation of the maximum amount of pollutants that water body can handle before it's going to exceed its standards. Okay, and so in order to accomplish that, they need to have flow data. Okay, and we are collecting flow data. We have been for at least two of the last 4 years now. And that's what I was talking about with using the oranges. I know it seems kind of bizarre and really old school, but it works, okay? So we drop oranges on one side of the bridge down to the other. That gives us a velocity. We have a cross section that we measure across our bathymetry across the stream. And then we have that established. And then every time we go back to sample, we take a stage height. Using that data, we can actually calculate flow. And then the flow is used to be put into this TMDL modeling that goes on, okay? So I guess that's the long, I tend to be a long-winded person. So that's my long answer, or short answer for that matter, to the answer, to the question.
Perfect. A question from Becca, actually,
Okay.
who will be on in a few minutes. But she was asking if you've looked at cover crops as a soil nutrient retention possibility and what those crops might be.
Yeah. So it's kind of funny whenever I talk about some of this stuff, and you have people who are pretty savvy like Becca, they'll always bring up that, well, have y'all tried this kind of BMP, cover crop, or this kind of thing. So here's a plug for Natural Resources Conservation Service, one of our partners that I was just mentioning, NRCS. These guys have been doing this kind of work literally since the 1930s. They were put in place. They used to be called the Soil Conservation Service, okay? How did they come around? In government, we create regulations and we create agencies in response to problems. The Soil Conservation Service was created as a result of the Dust Bowl, literally a gigantic erosion event where you had legislators with sediment, dust from the Midwest on their desks in Washington, D.C. All right. So that's the SCS, our Soil Conservation Service. They later became the NRCS in the 1980s. Those guys have been working at all these metrics for how to combat erosion and nutrient runoff and all that kind of stuff. They have a BMP for every crop out there, utilizing cover crop, intercropping, all of those kinds of things. Just to give you an idea, I mean, from my bio, it's not clear, but my background really is anthropology, which has nothing to do with this, and agronomy, okay? So I'm a studier of agrons, not a real thing, but agronomy, yes, it's soil and crop science. And my focus, I have an undergraduate and a master's degree in soil science. And so that was really my focus. And so that's how I know I have an intimate knowledge of that kind of stuff. And yeah, so the NRCS, when they're going to be working with the farmers, they have that all worked out. So right now, if you go up and down Bayou Lafourche, you will notice that there's more and more people planting soybeans rather than just sugarcane. Well, the soybeans in many cases are actually just cover crops. That's to impart more nitrogen into the soil. And in many cases, the farmers just go in, they never even harvest the soybeans. They go in and they'll plow in the soybeans to add more nitrogen into the soil. But see, that's that organic bound part of the nitrogen. And that gets held by the clay minerals and the organic matter tighter than, say, nitrate, nitrite, that's usually the big culprit when we see nitrogen runoff. It's usually in the form of nitrate, nitrite, because the organically bound stuff is usually held by the soil a lot tighter, and it's less prone to running off. So just like I was mentioning for a sugarcane, one technique might be leaving the chaff on the field. And like I said, NRCS has a variety of different different methods. And so usually the take-home message here is that it's usually not a technological problem. It's usually a sociological problem, a people problem. Convincing people that, hey, you need to go and fix your home sewage system. Okay, well, I don't see it. It's not work. It looks fine to me. I don't smell anything or something like that. Yet they have standing water in the yard where the kids are running through it and the dogs running through it, and they're tracking that into the house. Okay, so it's usually a sociological issue, It's usually not a technological problem. This isn't like high-end glamour science, like I mentioned before, it's not rocket science, but there's some basic things that need to happen to restore it. And it usually comes down to people making decisions on the land. That's the key. So again, another long-winded answer.
Arturo has a question about what is the greater source of pollution? Is it home sewage or pasture land crop runoff? So this kind of goes in with what we were just talking about.
Yeah. So it goes directly to land use, like I was talking about in the beginning. So yeah, land use is one of those key terms in watershed management. And the reason is because we are not talking about permitted discharges, okay? When I'm talking about all of the pollution sources, these are not regulated discharges. So when I say permitted, I'm talking about a regulated discharge. So if we think about like, Thibodaux has a municipal sewage treatment plant that services a huge portion, a portion of Lafourche Parish that's in city of Thibodaux. All right, so that is what's called a permitted discharge. They have to apply for a permit. The regulations clearly state, under regulations, they have to apply for the permit. Then by the state of Louisiana, they're granted a discharge permit. And that comes out of, you think of it as a single pipe. That's called point source. Now, what I deal with when I'm really talking about watershed management, we talk about everything else. That's natural sources of pollution, as well as what's called rainfall runoff or non-point sources of pollution. All right, and so how do you combat that? It's diffuse. How do you know where it's coming from? You have to look at land uses. If you know your land uses within the watershed, you can decide, okay, in this area over here, well, that's going to be pastureland runoff. That's that's the source of your fecal coliform bacteria. Over here, well, that's all residential. The cause is most likely going to be individual home sewage systems. Another term for that is also on-site disposal systems. You'll see that in the literature as well, the gray literature anyway.
Sorry.
So to speak. Gray water, gray literature. Okay, another word right there.
We were one mind right there. Clayton is asking if you have funding to support other sewage and septic issues in other parts of the estuary.
Yes, thank you for asking that. I'll pay you after the presentation. Yeah, so we, this is we got pretty excited about this idea. It's a big deal. So we're working in the Bayou Folse Watershed right now. And so far it's chugging along pretty successfully. And so my colleague, Siva Nuna, went out the year after I got funding from Gulf of Mexico program, and she applied for a Gulf of Mexico program grant and got even a bigger grant, okay? So that grant actually goes through LUMCON, through our fiscal and administrative agents at LUMCON, and that's a nice big grant. She's got about $700,000 there, and that goes actually, that instead of her having to kind of piecemeal all of these different funding sources and stuff together like I did, she has money for sampling as well as to pay homeowners, to fix their home sewage systems, all in that grant. So that's really nice. That's a huge feather in the cap of LUMCON and BTNEP. And so we are actively, we have the contracts in place with the labs for the sampling. We have the contracts in place for with South Central Planning to work out the contracts and pay the homeowners. And then now it's all a matter of us kind of getting restarted. We've had some downtime, which I didn't talk about. Everyone's been impacted by COVID-19, and of course we are too. It's diminished the water quality education that we can do. Fortunately, we have venues like this one where we can do it, but it's also diminished or it's kind of put us in a downtime for a while in being able to canvass the watershed with South Central Planning and working out the agreements with homeowners to pay the homeowners. But yes, thank you for asking that question. And yes, we are working in another watershed within Louisiana. Keep in mind, if you don't know it yet, Bayou Lafourche is the drinking water supply for the whole region. That's right. We get our drinking water from surface water, and there's all kinds of interesting things that can happen with surface water. Okay, it's prone to more pollutant sources, and Bayou Lafourche is no exception. But I just want to emphasize, Bayou Lafourche drinking water is perfectly safe. It's very good quality. It's treated, just to let you know. But we are trying to work in the Bayou Lafourche watershed to try to help our drinking water sources do better. All right. So yeah, thank you for asking that question. That was great.
Very good. It is 8:15, so I am not going to ask you any more questions, but I do have a question, 2 questions from people, and they're great questions. So Andrew, if you don't mind, I'm going to send those to you through email, and if you could just give me a response to those 2 questions, another one from Arturo and one from William, I will make sure that they get the answers to those questions.
Okay, great.
With that, I want to thank you very much for giving us a presentation tonight. This is a very local issue for us, and it's a very important one locally. So thank you so much for doing that. With a couple of minutes, if my audience doesn't mind, I'd like to bring Becca back on and introduce you guys to my marine educator at LumCon. So this is Rebecca Frohwein. We call her Becca. She is one of my staff members. I just really want to introduce her because, like a lot of countless others at LumCon, she helps us keep the gears moving and turning and work behind the scenes to really make these kind of things happen. Also, if something happens to me, somebody doesn't like jokes anymore or anything like that, Becca is bat and cleanup for me in case I can't make it one night. So I just want to make sure you guys have a face if that is ever the case. So with that, remember, if you attend 10 LumCon Science Talks, you'll get an RV Pelican Challenge coin. For those of you who reached your 10th talk at the last talk, I'm a little bit behind in getting challenge coins out, so I apologize to you profusely for that, and I will make sure your challenge coins get out this next coming week. With that, join us on September 3rd for our next LumCon Science Talk, where our presenter will be, and sorry if I slaughter your name, but Bingqing Lui, who is a postdoctoral researcher with the Water Institute of the Gulf. And so she'll be talking about her research using remote sensing techniques and stuff like that. So be on the lookout for registration information for her talk on September the 3rd. Again, thank you, audience. You are amazing. And Andrew, thank you for the talk. Becca,
thank you guys for this opportunity.
Thank you for your hard work.
Really appreciate it.
Thank you, Andrew. Everybody, take care of yourselves and take care of each other. That's important. I'll see you on September 3rd.
All right. Bye.
Good night.
Okay.